So hello and welcome back. So in this video I would like to talk about a little bit about some basic concepts of electricity and electronics. Well, basically I have been doing some basic course on electronics, but unfortunately because of copyright problems I cannot publish any of that course right now. But there are things that I can pick from that book and talk about them here. And of course it's good for me. I can set up my own lab, different things that I have here. And well, I have been also having problems with my own test equipment that, well, I had to take care of, so I just simply sharing my work with you over here. So basically, first of all, what we want to talk about is there are a few things that we can talk about here. The first one is the concept of voltage. The concept of voltage. And the concept of probably voltage drop, and there are a few more things here. Of course I don't know how far we can get in this one video, but then we will talk a little bit about the concept of current. What is current, how you can measure it, and basically what that means in simple terms of, basically simple lamps and a power supply and an amp meter and a voltmeter connected to that circuit. And basically how to basically measure current in a circuit, and then the voltage, basically the concept of polarity. The concept of polarity. So now, first of all, what voltage is. Basically, voltage is so basically what happens in a circuit. For example, let's say that you have a lamp, for example, and of course in a typical lamp you have basically two wires connected to a lamp, something like this. So for example, let's say that, this is a lamp. This is a typical, for example, 12 volt lamp. And of course, if your lamp is not connected to a voltage source, of course it's not going to light up, or it's not going to turn on. And the reason for that is that basically there has to be a voltage source in this circuit. There has to be some sort of voltage source or some battery, for example, in this circuit, so that it has two polarities, basically two poles, basically positive and negative. And then this battery, what it does, it basically pushes the electrons in this circuit and makes them basically keep moving around this circuit, and that of course creates the current in your circuit. And then it just keeps pushing the electrons to move and circulate in this circuit, and as a result of that your lamp basically turns on, and then you will see light coming out of a lamp, for example. Now that's all good. So that's basically the concept of voltage. So voltage is simply that simple thing. Now, for example, in the case of you have probably seen these 9-volt batteries, for example, and there is 2 poles up here. If you open this, there is 2 poles up here. One of them is positive, one of them is negative, and then if you connect your lamp to this battery, of course, then your lamp is going to turn on or light up or start giving out light. Now in an electronics lab, what we do is basically we use instead of the battery here, we use something called a power supply. Which is basically something like this. So this is a basic power supply, for example, that has basically one rail up here, another rail down here, and then you have, for example, another output here, and all of your outputs you get from these terminals, and then your voltage and everything and your voltage and current is also you can basically you can control your voltage and your current on each of the rails, and that's basically power supply. You use this instead of using a battery. And then you basically connect this thing to the one outlet, and then the output is going to be the kind of voltage that you can use for, I apologize for this camera, because okay, so then the voltage, the power supply is basically as I showed you, it's a box over here. It has a cord that you simply connect to the one outlet, and then out of the output terminals you can get some voltage, for example 9 volt, 10 volts, depending on your needs, and then you can connect it to some sort of circuit like this. So that's basically a power supply. And then this power supply, what it does is provides a voltage. It provides a voltage for you, and then that voltage is basically keeps pushing the electrons around this circuit, and then of course your circuit starts working. So that's voltage, and of course voltage you can measure it. So let me show you how we can measure some voltage. Okay, so in case of, for example, in the case of this power supply, you can measure your voltage. Take care of this camera. Okay, so here is the power supply. So here's your power supply, and you can see that on this power supply I basically have 2 rails, meaning that you might simultaneously need two separate voltages. For example, you're working on a circuit, and then for example this circuit needs 2 different voltages for the power supply part. So then you can simultaneously, for example, use this rail and set it to, for example, 5 volts, and then use this rail, set it to 10 volts, and then simultaneously get 5 volts from here, then 10 volts from here. So that you can do. And then, for example, this power supply has another another rail here. Not you couldn't call it the rail. It's just some adjustable output, 3 to 7 volts, for example. This is, for example, if you're working on a low power circuit, like for example a microcontroller or a small circuit that doesn't need much current, you can, for example, adjust it to, you can use a small screwdriver to turn this pot in here, and then you can adjust this voltage, and then of course you can use this voltage for some circuit. And the voltage that you set here, so you can see that you have a voltmeter, analog voltmeter over here. So I can turn this potentiometer, so you can see that this needle is moving. As I'm moving this potentiometer in a anti-clockwise direction, the voltage is decreasing. Now it's around 5 volts. Here is 10, 15, and 20, for example. As I'm moving it towards in a clockwise direction, it's increasing. For example, now it's 10 volts, 15 volts, and so on and so forth. And moreover, on this power supply, and on most power supplies that have a analog meter, the analog meter is actually 2 meters in 1 meter, meaning that now you can see this switch over here. On the top it's written volt, and on the bottom it's written amp, meaning that if I put this switch in the top position, you're reading voltage over here. If I put it in the bottom position, you're reading 0, meaning 0 ampere. And of course I can connect some sort of load to this power supply, and we can test it. So you can see that, for example, I have these lamps. And I have connected them together in parallel. In parallel meaning that I have just connected them end to end, just like this. And you can set your voltage to, for example, these are 12 volt lamps. So I set my voltage to 12 volts. And this way I'm actually measuring my voltage on this voltmeter. And set my voltage to 12 volts, and this is these are the terminals related to this rail. So if I connect these wires over here, you can see that the lamps are now, both of them have been, and they are basically, they have turned on. And well, that's basically what the power supply does, and that's actually a circuit, what we did right now, although it's a very simple circuit. So there are other ways to measure voltage. For example, you can use voltmeters. Now, for example, this multimeter over here, with this you can measure direct current, or volt DC, volt AC. This is alternating current, and this is amps DC, amps AC, and ohm. So with these two you can measure current. With these two you can measure voltage, DC AC, and this is ohm, which is basically resistance. And if you want to measure, for example, volt DC, which is the output of this power supply, so you can set it to volt DC, and then you have, for example, these probes over here. So you connect the probes to, for example, 0, which is common between these three, and then the other one to volts. And you can see that the probes are color coded, meaning that you have a positive, meaning that you have a red one and a black one. So if you usually connect the black to the 0, which is common, and on this multimeter, this pole is actually negative. So this is actually negative, and I'll tell you what that actually means. And then this pole over here, or this terminal, is positive. Now if I have a voltage source, for example this power supply over here. Now on the other end of the probe I have again two probes. One of them is red and one of them is black. So here you can see that I've connected the red one to the positive pole here, and the black one to the negative pole here. And here again I have to do the same thing. So here on the power supply, this red terminal is the positive output, and this blue one is the negative output. So I have to then put the positive in here and put the negative in here. And you can see that I can read, for example, 12.2 volts, which is the voltage here. And if I change the voltage on the power supply, there you can see that the voltage is changing. I can go, for example, all the way up to, I don't know, 20 volts, for example. 20.2. So that's basically voltage. Now this is around 12 volts. Now the next thing that we wanted to discuss is voltage drop. Now voltage drop is something that has something to do with series circuits and parallel circuits and things like that. So we'll have to talk a little bit about series and parallel circuits before we can get to that. So let me actually draw a circuit over here, and first show you what I mean by voltage drop, and then we can get to the rest of our work here. So I'm going to move this out of here for now. So basically what voltage drop is that, let's say for example you have some sort of circuit, you have some sort of load, over here. So this is any sort of load that you can put on a voltage source. For example, the lamps that I showed you before, that could be a load, and then that load you can put it on a power supply, and that load is consuming energy, and that we call a load. Some people denote them by L, some people by R, I don't know. So you can do anything that you want as long as you know what you're doing. So I'll call them, for example, I call it R1, meaning load 1 or resistor 1, and then I will have another load over here, and then I'll call this R2. So these are two loads here. Now, and then I'll connect both of these to a battery, or to a power supply, or to a voltage source, whatever you want to call it. Now what we have here is actually a series circuit, meaning that you can see that if this is, let's say that this is R1 over here, and this is R2, so you can see that R1, one end of R1 is connected to one end of R2, and then you'll get basically two points over here, and these 2 points, one of them is connected to the positive pole of the battery, the other one is connected to the negative pole of the battery. So now these two resistors are connected in series. As opposed to this idea of series, you can connect the same two loads in parallel, meaning that you have, for example, you have your R1 in here, and you can connect it to, for example, R2 like this, and you can connect it to R2, and then this combination can be connected to a battery, positive and negative, for example, and this is R2. Now you can see that in this configuration, basically I have connected one end of R1 to R2, and then the other end of R1 to the other end of R2. So this is called parallel. Now there is a whole lot of differences between series and parallel when it comes to circuit analysis, and we will get to them one by one as we go along. But for now, or at least in this video, we want to talk about this circuit, and then what happens here to your voltage source as it goes around this circuit. So now, when you connect your power supply to this circuit over here, it just keeps pushing the electrons around the circuit over and over again, and you have some voltage source over here, and it has some sort of, and you can, of course, as we saw over there, you can measure that voltage. For example, let's say that your voltage is 12 volts. Let's say that your voltage is 12 volts. So then, if your voltage is 12 volts here, and if your two loads are connected in series, that voltage is going to be shared by these two loads, meaning that, let's say that, for example, R1 is exactly equal to R2, meaning exact same loads, and so then your 12 volts is going to be shared half and half by these two loads, meaning that this resistor will get 6 volts, and this resistor will get 6 volts, and then 6 plus 6 is equal to 12. So, but of course, if you have a larger resistance here, if you have a larger resistor here, then the voltage is going to drop. Then basically you will have the higher your resistor, the lower the voltage drop on that resistor is. So then it's going to be some sort of relationship between these two resistors, meaning that if R1 is equal to R2, then R1 by R2, for example, is going to be equal to, let's call this voltage drop, for example, V1 and V2. So then this is going to be equal to V1 by V2. And now you have some sort of relationship between V1 and V2, meaning that if you increase R1, then you'll have to decrease V2, or if you increase R1, you'll have to decrease V2. So this sort of relationship exists between these four values. And of course you can cross multiply here. You have R1, for example, V2 is equal to R2V1. This is, and we will see how that works in a circuit, so you don't need to worry too much about the theory here. It's a very simple thing. Now let's first of all, R1, what I mean by R1 is the measure of the resistance of this load. So what I'm going to do here, I'm going to measure my R1 here, I'm going to measure my R2 here, and then connect them in series, and then measure the amount of voltage drop on these two resistors and see basically what happens. So now let's set this up and see what we can do with this experiment. So now what I'm going to do is basically the loads that I have are, it's too high. So the loads that I have are these two lamps, right? I want to connect these two lamps, and I don't want this camera to be moving around on its own. Okay, so the loads that I have are these two lamps, and I have already connected two pieces of wire to these lamps so that we can work with them. So now first of all, I want to measure the resistance of these two lamps. So I'm going to basically, you can see that I have this lamp over here. There is a piece of wire connected to it, and the other end of the wire is right here. So I set this to ohm. This multimeter, I set it to ohm because I want to measure resistance, and then I have to, of course, connect this probe to ohm because I'm not measuring voltage anymore. And then if I connect this like this, the two probes, if they are connected here, you can see that I'm measuring 0.00284, which I'm not sure about. Let me actually connect this thing over here. So ohm and ohm. And you need to be careful with your lamp, otherwise you could break it. So now I'm measuring even a lot more. Now there is something wrong with one of my probes. I don't know which one. And I have okay, so let's see what happens with this probe. I have actually ordered some probes, some multimeter probes, but I haven't gotten them yet. So now I measure this again. 3 point. So I'm reading 0. I'll just take it as 0.00332. Well, I'll connect these alligator clips over here, right? And then I connect this over here. You see, as I'm connecting more wire to this probe, as the wire is getting longer, the resistance is increasing. So or let me do something else. Let me actually measure the resistance of the without the probe. So I'm going to go here and here, and the resistance is 0. So it's 0.0016. So let's take it as 1.6. So 0.0016, if I was reading kilo ohm here. See, I'm reading kilo ohm here. So it's 0.00, let's take it as 1.6. Now I have loose connection here, so it's actually 0.0016. And it's giving me kilo ohm. So I have to multiply this value by 1000 to get ohm. So 0.0016 times 1000 gives me 1.6 ohms. So this lamp over here, the resistance of this is 1.6 ohms. And the other one is again the same thing. I'll take it as 1.6 ohms. So now it seems that my loads are exactly the same. So now the voltage drop on these loads must be the same as well, but let's see what happens. Now I'm going to build this circuit. And I'm going to basically you can see that these two wires are coming from one lamp, these two wires are coming from another lamp. When I say series, I mean that I connect this wire to this wire and just leave it alone, and then I connect my power supply to these two wires, to this wire and this wire. So then this is the end that I'm not working with anymore, and then these two go to the power supply. So then I hope that you're seeing the power supply actually. Okay. So now what we can do is that I'll set my voltage to 12, and I'm not limiting the current here. The voltage is at 12, and this is my output. And then let me see. So now you can see that. Let me come down here, because that way I cannot actually work. Okay, so let me see. It's not really easy to work with. I don't know how some people work on YouTube with a camera. It's really not an easy thing. Oops. See? Okay, so I need this piece of. I apologize for this lousy setup. Okay, so now let me connect another piece of flow to this power supply. So now I have 12 volts on my power supply, and I can actually put some multimeter over here and get rid of that thing. So, and this is the same thing as the multimeter I showed you up there, but it's a cheap one. For now, so I set it to DC volts, and if I measure this voltage, you cannot see, but I'm reading around 12 volts on here, around 12 volts on here. So now I get the two lamps, and you see this end is connected, these two ends are connected together, and I connect the lamps to the power supply. And you can see, I'm not sure if you can, but you can see that the lamps are now a lot less bright. I mean, a lot less bright than they were before. I can show you what I mean by that. So now let me actually connect them in parallel. So I'm not connecting them in series, but in parallel, meaning that the two lamps are just simply connected together end to end. And if I connect my power supply to them, you can see that they are a lot brighter than before. So this is in parallel. And right now, even the voltage is around 10 volts, meaning that this power supply has some problem. When there is load on it, the voltage decreases a little bit. So I increase the power on this to get it back to 12 volts, and you see that the lamps are very, very bright, right? Now what I'm going to do is that now you can compare this to when the lamps are connected in series. Now I have these two ends, and these two ends, just I'm not working with that anymore. And this is in series, right? So now in the parallel mode, you can see that I have these two ends basically. Let me show you a schematic of this circuit. So if you have your lamps connected together in parallel mode, you have one lamp over here. You have one lamp over here going over here, and you have another lamp over here going over here, and you're connecting that to your power supply. And in this case, you can see that the lamps are a lot brighter because you have, let's say that you have 12 volts over here. And so logically, you can see that your 12 volts, basically this is positive 12 volts and this is negative 12 volts. If you just follow the leads here, you can see that here you have again positive 12 volts, here again negative 12 volts. And the same thing goes here, positive 12 volts and negative 12 volts. So basically the full voltage of the voltage source is on both the lamps, so both of the lamps are basically much brighter. But over here I have positive 12 volts, and here I have negative 12 volts, of course. So this negative 12 volts goes over here. So now positive 12 and negative 12 is applied to these two lamps in this configuration, meaning that this lamp is going to get only 6 volts, this lamp is going to get only 6 volts. And so basically they're going to be a lot less bright than this case, because now this lamp is getting only 6 volts, this lamp is getting only 6 volts. But in this case, the lamps, each of them or both of them, are getting 12 volts. So that's that. Now let me show you what voltage drop actually means here. So if I connect my power supply here, which is now set to, see now the lamps are connected in parallel, and if I connected them to the voltage source, I'm getting basically both lamps are lit up and they're very bright, right? Now I can disconnect them and set them in series, and I put the voltage source in series with the two lamps. And now in this case, you can see that the lamps are not very bright. And now let me show you one more thing, and that is if you have a multimeter here. Let me actually, you cannot read that multimeter, so let me actually give you the other multimeter. So I set this multimeter to 2 volts, hopefully. I set this multimeter to volts, volt DC. Now I probe one of the lamps in this series circuit. So you can see that here you're reading 6.9 volts. Now I probe my power supply in this circuit. It's 13.4 volts, right? And so here I had basically 6.9 volts. Let me use these alligator clips. That way my job is going to be a lot easier. So one of the lamps is, I go to one of the lamps, and that is and that is 6.9 approximately. Now I'll go to the other lamp. And probe the other lamp. And now I'm getting 6.4 volts. Now 6.9 plus 6.4 is around 7. What is that? Let me see. Where's my calculator? Well, I cannot get anything out of this computer right now. So it's around 6 plus 7 is 13, around 13.4 volts, right? Now I'll probe the power supply, the whole power supply here, and I'm getting 13.2 volts, meaning that the whole power supply is being basically shared by the two lamps. Now there is one more thing here. And that is, let me see. Now if I connect my power supply, unfortunately I cannot show you what I'm doing down here and both up there, and that's a problem. Right, I just have to say it. There is no other way for right now. So now I told you that there is a positive pole on my multimeter. There is a negative pole. Probably you could actually see the multimeter, digital multimeter down here. Let me see. Okay, so I have another multimeter. It's not easy to read this right now for you, but you can read this. So this is the exact same thing that we had up here, just very cheap version, very cheap. So you can see that the lamps, both of them are lit in series, and this wire is coming from my power supply. This is positive, this is negative. So I can set this to volt DC 20 volts and probe this power supply. And you're reading 13.3 volts, right? And then now I'll probe one of the lamps. This is basically this is one of the lamps, and then these two will be the other lamp. So one of the lamps here is 6.8 volts. The other lamp is around, I don't know, let me see. This is positive here. So this is 6.5 volts. Which if you add them up, you'll get around 13.3, which is the power supply here is being shared by the two lamps. Now you can observe here that the voltage drop on these lamps actually has a polarity, meaning that if I probe this lamp over here, so let's say that this is one of the lamps, the voltage drop on this lamp over here, it does have a polarity, because this 6 volts, something around 6 volts that we got here. So this is the positive rail on your circuit. So this is going to be, if you put a voltmeter, for example, over here to probe the voltage here, let's say you put a voltmeter here. So this is going to be, if you put the positive pole of the positive terminal, or the positive probe of your voltmeter here, the negative probe of your voltmeter over here, you are going to get positive, for example, 6.3 volts. And if you put the negative probe of your voltmeter over here and the positive probe of your voltmeter here, you're going to get negative 6.3 volts, because the voltage drop here has a polarity. And the reason is that, well, basically this whole rail over here is connected to the positive pole of the battery, and so this point is actually positive. When you connect it to the positive probe of your voltmeter, you'll get a positive voltage or a positive reading on your voltmeter, otherwise a negative reading. Now let me show you that over here. So on this voltmeter, you can see that I have two probes, and then one of the probes is connected to the positive terminal of the voltmeter, which is this one over here, and the black one is connected to common, which is the negative probe of the voltmeter, and it's set to volts. Now in this circuit, the power supply comes in through these two alligator clips, and this is positive and this is negative. So you can see that if I probe this power supply over here, I'll get 13.5 volts, and there is no negative here, meaning that I'm reading a positive voltage. Now if I do the reverse of this, if I put the negative lead on the positive power supply rail, you can see that now I'm reading negative 13.29 volts, meaning that I have to change the meaning that the polarity is reversed here. Now the voltage drop that you see on these two lamps is also the same story, meaning that the voltage drop, for example, these two wires together is going to make one lamp. So if I set my multimeter over here like this, I'm going to get 6.88 volts, which is a positive reading. Now if I reverse the order here and probe the voltage like this, I'm reading negative 6.8 volts. So that's basically the voltage drop polarity in a circuit. And there is one more thing that you could also that you have in a circuit. So on this power supply, you can see right now that these two lamps are connected to the power supply, and of course so this is there, you're reading the voltage coming out of these two terminals. But if I set this switch to the bottom position, you're reading some current being measured by this amp meter, which is around 0.5 amps, or a little more, 0.5, 0.55 or something. Now you can actually measure this current. And how can you do that? So you can use some sort of so for example, you can use this as a current meter, or as they say, as an amp meter. So I use the probe. I use this probe over here, right? And an amp meter is basically something that goes in series between your power supply and your load. So now I just simply connect the leads of my amp meter over here, and I have two leads over here. I have these two leads, and then I'll put these two leads in series between the power supply and the two lamps, which is the load in this circuit. So now, if you observe here, as I disconnect the lamps, this amp meter is just dropping down. See? I don't know if you can see it actually. See, I'm connecting it and disconnecting it, and the needle is going up and down. So now I simply put this amp meter, I put this on amp and amp AC, DC, and now this becomes an amp meter. And I put this amp meter now between the load and the power supply, and I don't know which one is positive, which one is negative. So positive goes to positive, negative goes to negative. And you can see that I'm reading 537, 535 milliamps here, which is, if you multiply this by a 10 raised to power negative 3, it becomes 0.536 amps, for example, which is what we are reading here. So that's basically how you basically do a current measurement here. And now let me show you this down here as well. Okay, so to do this kind of measurement, we can actually do it over here as well. So let's say that this is your, let me get this out of the way. Okay, so let's say that let's say that this is an amp meter, right? So you can put this on amp DC, and it goes something like, let me get the microphone here. So this is volt AC and this is amp DC. So it goes all the way to 200 microamps, 2 milliamps, 20 milliamps, and 200 milliamps. So the highest range over here, 200 milliamps, is much lower than the current that we have in this circuit, which is basically 500 milliamps. So I'll have to set it to 10 amps. And when I set this to 10 amps, I have to disconnect this lead or this probe and connect it to 10 amp DC, like this. And now I have two probes. One of them is positive, one of them is negative. And, well, the circuit that I have here, these two leads are coming from the power supply. They're around 12-13 volts. And I have connected these two lamps in series, meaning that I connect my power supply to these two wires. So then if I connected them basically like this directly, of course the lamps would turn on like this, but the amp meter is not there. So the amp meter has to be connected in series with the load. So what I need to do here is I'm going to connect these alligator clips to this amp meter, and now this lead is the positive probe of my amp meter. So I disconnect this circuit over here, and now the circuit is broken. So now this amp meter has to go between the load and the power supply. I have not touched this. I have disconnected only one wire here. And then these two wires coming from the amp meter have to go between these two. Now one of them is positive, this one. So I connect it to the positive pole of my circuit, which is coming from the power supply. And the other one is negative coming from my amp meter. And there I connect it to my circuit. And here you see you are reading 0.53 amps. And that is basically what we read on the multimeter over here as well. And we can do that here as well. I guess we could, I don't know. Here you have, for example, DC milliamp. It goes all the way to from 50 microamps all the way up to 0.25 amps, meaning that 250 milliamps. But this is not going to be enough, for example, for this circuit. For very sensitive work and very low consuming electronic circuits, you can use this. Otherwise you will have to have a good amp meter. So this amp meter can measure up to 10 amps DC. This amp meter over here can measure all the way up to, I guess, 2 amps, and this also, I guess, 2 or 1 amp, something like that. So that's basically all of these concepts here that we wanted to talk about: polarity, current, voltage drop, and voltage. So we will keep going through the book, and then whatever concept I see that you can use that we can that we can use in order to create some videos like this. I will put them over here to show you what sort of book I'm using. So there is a, if you want to learn electronics, in my humble opinion, the best book that you can ever find, and I have, of course, I have done my research and I have done my homework as well, because I have been working in I have been working in electronics for many years. I don't know, probably 25, 30 years. From the time I was a very, very, very little kid, like 5, 6 years old, I was just doing different things in electronics, and then it was my job for a while, for many years. So, but well, I ordered many very, very famous electronics books, and but there is no way that you can learn electronics from those books. They talk about different things, but the basics are not there. So what you can do, well, I will talk about this in another video. This video is already long enough, and then now I'm getting off topic, so I will talk about this in another video. So thank you, and I'll see you in another video. Thank you.